Hello Year 10. This lesson is all about the composition of inspired and expired air. What we mean by composition is what actually makes up, what gases make up the air that we breathe in, inspired, and the air that we breathe out, expired air. So there's a section in your syllabus that says that you need to know about the percentage composition of inspired and expired air and the reasons for the differences. So we're going to go over this now with this table. So the composition of inspired air. Air that we breathe in is mainly nitrogen. It's actually 78.1%. They round it up to a whole number in WJC to 78%. And most of this nitrogen is unreactive, it's inert, okay, and we don't use it for any purpose in our body at all. However, the air that we do need and that we breathe in is oxygen, okay, or the gas that we need out of the air. And it's 20.9%, so if we round that up to a whole number, that would be 21% oxygen of the air that we breathe in. We also breathe in a small amount of carbon dioxide. Now, this can be quite variable in inspired air. It's between 0.03 and 0.04% carbon dioxide. And water vapour also varies dependent on the day. So if it's quite a damp day, quite muggy with a lot of water vapour, there will be more. But if it's a drier day, it will be less. The other gas that we breathe in are the noble gases. And these are very unreactive, inert gases, okay? Helium, argon, neon, krypton and xenon, okay, and they come in at less than 1%, 0.94%. Now you should be able to see on the other side, on the other column, the difference between the inspired and expired air. So we still breathe in the same amount of nitrogen and the same amount of our noble gases, 0.94%, okay, but what we can see is that the oxygen levels in the air that we breathe out are much, much lower. So if there are 21% coming in, there are only 16% of oxygen is breathed out. So why is that? Why is there less oxygen in the air that we breathe out? Well, we use the oxygen in our process respiration, aerobic respiration, and we make the waste gas carbon dioxide. And this explains why it's suddenly gone from 0.03, 0.04% in inspired air to suddenly 4% in expired air of carbon dioxide. And this is because it's been made in respiration. The amount of water vapour is also variable, but it is definitely more than in inspired air. If you take your hand for a moment and just put it in front of your mouth and breathe on it, you should feel that the air feels warm because of the heat energy that is being released, okay, from respiration in your body. But it is also moist, that air, because of the moisture, the water vapour that you are making in your body cells when they carry out respiration. So on page 23 in your book, can you put Daviad on the top of the page for me, please? And I would like you to write for me a clear either one paragraph or two paragraphs. It might be an idea to split this up into two paragraphs. And in the first paragraph, explain the similarities between inspired and expired air. And when I say explain, I want to know why there is that amount, okay? And then explain the differences, why we have less oxygen in the expired air, more carbon dioxide, more water vapour, but that the nitrogen and noble gases stay exactly the same. So pause the video at this point. This task should take you around about 10 to 12 minutes, okay, to put some paragraphs together. Don't forget this is extended writing, so I am expecting capital letters at the start, full stops at the end, and the use of paragraphs, and make sure that your spelling is correct. Please, please, please do not be tempted to write formula as a shortcut. In extended writing QWC answers, they are expecting to see the full words. So don't use CO2, H2O, O2. Use the full words, carbon dioxide, water, vapour, oxygen, okay, as you've been taught. Thank you. So pause the video. Okay, so hopefully you've got your paragraph written down for you. Now, back in year 8, you will have done this as a practical task. I have a little video that Mr. Hancock will try and get up on the screen to share with you to show you this part of the experiment and the next part. So this is page 24 in your book. The test for carbon dioxide is that when you bubble carbon dioxide gas through lime water, okay, lime water turns a milky or cloudy colour. So normally we would be getting you to do this in the class with a straw and a test tube, but because of current conditions with COVID, we're not allowed to ask you to breathe out into straws and then have to dispose of them, okay, because of the risk of spreading COVID at the moment. So any experiments to do with breathing have unfortunately been stopped. And then on the same page underneath, you have this set of apparatus. Now, you'll see this in the little video with Mr. Hancock, okay? This is called the Huff and Puff apparatus, is its kind of like a slang name, I suppose, okay? And in this set of apparatus, we've got a series of tubes coming from the mouthpiece. Some are long and some are short, okay? Both tubes end up in boiling tubes with lime water, clear lime water to start with, and they are sealed off with the corks at the top. So the idea in this experiment is that somebody will breathe out, down through the mouthpiece, and then breathe in through the mouthpiece constantly. So they'll be breathing in and out, okay? And as they breathe in and out, one of the tubes will bubble at each time. So just take a moment, see if you can predict for me, just by looking at the diagram, which of those tubes, A or B, is going to bubble when you blow out. So think about when you're a child and you might have a straw for the very first time and you blow out through it, okay, and it makes whatever drink you've got in front of you bubble, okay? So which tube is it? And then if you imagine breathing in through the mouthpiece, which of those tubes do you think is going to bubble? So if we deal with expired air first, breathing out. So in this arrow here, we're breathing out down our mouthpiece. Now air can go in both directions, but can you see that this one ends, okay, above the lime water, above the liquid layer, whereas this one goes straight down. So as we blow out, the air will travel down here and it will start to make this tube bubble. So tube B is testing for expired air. As we push air down into here, air can also pass back up out of this tube, okay, out this way. So if we switch to, rather than blowing out, to breathing in, sucking air in, as we suck in, we've got to be careful because sometimes a little bit of this liquid comes up the tube, so we don't want to suck in too hard, okay? But the air will literally come in through this side, the air that we're breathing in. It will pass into this tube here, into tube A. So tube A is testing for inspired air, and it will bubble. And then some of the air will pass up through the tube and up into your mouth. So if we get somebody to breathe in and out constantly over this piece of apparatus, okay, we find that it's this tube first, the tube B, that goes cloudy first, because we know that expired air has got more CO2 in it than expired air. In actual fact, when we look at our table that we filled in, it's got 21%. No, apologies. Let's start that again. It's got 4%, okay, carbon dioxide in it, whereas inspired air has got somewhere between 0.03 and 0.04%, okay? So there's far more CO2. This tube stays clear for quite some time, but it will eventually go cloudy, okay? The person who's breathing in and out, okay, it's going to take them a long time to get it to go cloudy, but it will go cloudy because there is still some carbon dioxide, but it is much, much lower. It's 0.04%. Now, there should have been a page in your booklet for you to be able to write this experiment up fully, explaining what's happening in both tubes. However, I don't think a page has been put in. So there is some lined A4 paper over on the side by the windows. If you can write this experiment up briefly, explaining which tube is testing which type of air, which tube is going to go cloudy first, and why, using these terms, okay? And then what we'll do is we'll stick that into your booklet so that it stays safe. So pause the video. You can use the diagram to help you to explain, and the arrows are on the diagram in your book, but you need to write clearly telling me which tube is testing inspired air and which is testing expired air. So pause the video whilst you complete page 24. Okay, the next bit of work I would like you to do in today's lesson is what we call a PISA-style scientific literacy question. These questions are designed to have quite a lot of reading with them, not always reading of text, reading of data, reading of graphs, reading of diagrams, and this one is about exercise. So it starts on page 33, if you turn to page 33, and it goes from page 33 up to page 36. Now, that might seem like quite a lot of questions, okay? There's a lot of reading definitely that goes with it. Some of the answers you may be able to find within the body of the text that you're reading. Some of them are based on your knowledge and understanding of the content of the work that we've been doing. So comparing aerobic, anaerobic respiration, equations for respiration, and things like variables, identifying variables. So I would say that this task is probably going to take you around about 20 minutes in the lesson. So if you can pause the video and complete those tasks for me, please. The last thing I would like you to have a go at doing, and if you don't get these completed in the lesson, then these are set for your homework, is some past paper questions. So page 37 is when they start. Page 37 is a QWC question. I know it says QER. They used to be called Quality of Extended Response. They're now Quality of Written Communication. So this means it's a 6-mark question, and it's testing your ability to use good written English. In other words, capital letters, full stops, paragraphs, spelling, punctuation, grammar. So it's about Dan working out on an exercise bicycle. He says he's fitter than Alex because his breathing rate returns to normal after exercise sooner. So can you design an experiment to test Dan's claim about comparing how the exercise affects his breathing rate, breaths per minute, on Dan and Alex, okay? So make sure you are clear. Make sure you put your description in sequence, well-sequenced order. And then the next few questions, these are actually in your booklet. So I'm just going to show you exactly what they look like. So they start on page 38, so you can see this question here. It's to do with the structures in the human lung. This one's out of 5 marks and is a foundation tier question. The next page is again a foundation tier question about the model lung that you've seen previously and is a 3-mark question. Some interpreting data about inspiration and expiration, which we've done earlier on in the booklet. This is worth 3 marks. Reading off data from graphs. The answers are then in the PowerPoint. So if you're getting stuck, the teacher can go over those answers on slide 67. Page, then, where are we? Page 38, 39, 40, 41. Page 41 is this one. This is probably the hardest question. It is a higher tier question here. So we've got percentage here that we need to be working out. So there's that part of the question about muscles contracting. And then it gives you an equation to use to work out the difference in concentration. Okay, so use that to help you. And then the last part of that question about the effect of increasing intensity. And again, if you're getting stuck, the answers are on slide 71 of this PowerPoint. Leave the next page, the one about peak flow, because we haven't covered peak flow yet, but you can certainly do the very last question on the back page. This question is about the human respiratory system and the mechanism of breathing. In other words, how the intercostal muscles and the diaphragm bring about expiration. Remember, this question is only about expiration. It's worth 4 marks, okay? Ignore the 7 marks at the bottom. That was for the total question. So 4 marks about expiration. So think about the 4 things that you need, okay, to be able to describe what's happening and explain what's happening in the lungs to bring about breathing out or expiration. Thank you, Year 10.